Hello everyone, welcome to this new Wii episode for the STM32 tutorial. And in the previous episode we have been building function, the first one to create as an output, to set your pin as an output, and the second one to set your pin as an input. But now what we are going to do is building more dry functions to compensate the whole thing and to give us more flexibility on how to build our code. After that, we are going to use the define, the dash define, within our main code to give it more significance when we play with our function and how to picture the variable within our code. Then finally, we are going to see together some code optimization idea that will help us to make our code more optimized. And that's just an idea for you how to play with those functions. So the board we are going to use today is the Nucleo F446CE, and the microcontroller is the STM32 F446 ZET6U. However, as we have seen in the previous codes, this is not the code we are building is not limited only to this board. So if you do have an STM32 F4 family microcontroller board, you can easily do the same thing. Hope you enjoy today, and let's start coding. So let's start by having our code more dry. But initially, so I'm taking really a clear project so we can see how we can add the functions we created previously. So let's go to project again and a new uVision project. And this is the old project we created. We are going to create in a new folder, and let's call it GPIO dry function. Okay, so we create this new project, and the microcontroller we are going to use is the STM32 F446 and then the GET. Okay, so you need to be sure which microcontroller you are going to use, and as we have discussed, this code should be able to get adjusted with all the microcontrollers you do have. So I'm putting OK here, and I'm bringing this window here. So we are going to use only the KIMSYS core and also the device startup. Okay, so it says it requires the C99, and this is what we are going to do. So first of all, we go to this option for target, and we just move this one, use default version 5 and then 6. And after that, we go to the tab C, C++, and we move from C90 to C99. This should solve most of the issue that we do have. Now, within the target, which is for me here, the STM32 F446ZET. Okay, and for the first source group 1, which is app, here, and let me create also at the same time the group for headers. Okay, so let me add the app code file. So let me go here and add existing files to the group app, bringing this one here again, and to add them, just C source file type, and the two files are available. So just double click to each one of them and then close. So we should be able to see them. Then for the headers, add existing file groups, and we change again the file type here to text file, and with extension .h, where we do find the GPIO.h. Okay, so let's quickly visit our main.c. This is the main.c we created previously, and one of the first thing that we can change, let me zoom in, is as we do have in GPIO.h here, and let me show you the structure again because I didn't focus in the previous one, and GPIO.c. In GPIO.c, we are already using this STM32F4XX.h extension, which already have all the mapping and the structures that we need. So we don't need it anymore. So just GPIO.c, this is here. So we don't need it anymore in the main. So the main one here, we are not anymore in need of this one. And you can see immediately that there is no error. So if I save and build, it's zero error, zero warning. So it's exactly what we expect, and just including the GPIO.h, the header file. Okay, so now let's jump on our try function that you'd like to create. So you see here we do have pin output set PA0, pin output set PA5. This is a little bit, I'm not saying a little bit, it's quite not a dry at all. And we don't want to have this kind of function working like this. We would like we would like not to repeat ourselves. So what we can do is create a function that goes through all of them and run it. And this is what we are going to do now. So let's go here. So this is the GPIO.c that we created from scratch. Let's close everything until the last one. And that's why I like this one. We can really see all the functions together. So here, what we can do is create a function it's a void because there's no output from this function, and we call pins with the S and set. So this is the function that will set up the pins itself. So for the pin set, the first input should be the list of the pins that we would like to set up. So we call it pins and here list. That will be an array of the list of pins that we would like to change. And after that, we are going to add the number of pins that we need to change. So here, pin number. And finally, char the state that we would like. We would like an output, an input, and for future video analog. So let's keep it for that, but we can just put state at this moment. Okay. And let's start our function here. And what we can do is initiating an I, and this one we will use for a for loop that we are standing now. So we are going to loop for I equals 0 until I is less the pin number. So pin number like this, and we are going to increment I++. After that, here we are adding a condition. So if, and before that, let me show you here like this. So we are going to, so we do have those states. So if here a state is equal to input, okay? So if it's equal to input, what we can do is each time we do have the pin input set, and what we bring here is the array for the pin input set at the position I here, and the setup that we would like to put is like this. So we set up this pin input like this, and we close this one, and we bring this. Then else, we just have to copy. So let's bring this else here, and we just copy this. We would like to keep ourselves very accurate in what we would like to do. So that's why we put the else if, and we do have this condition, and this one become output set. Output set. So now we are setting, and this is the function we created, output set. And so what we are going to do here is this function will be running through all the list and check if the pin, so if we wanted to have them as an input or an output. So doing so, we can have some optimization here. So let me make it a little bit big and still create two functions that will make our life even much easier. So we have the void, and we create the function pins input set like this. And in this one, we just want to input only these two inputs like this, and you guessed it, what this function is going to call. This function will call this pin set function here, where it will go to pass for this function, maybe a little bit smaller like this, yeah. So it will pass to this function the pin list because it's already declared, and also the pin number, but the state here, because it's an input, will be an input. And having so, we just need this function to run and to set as an input. Using exactly the same logic, we can create, so let's here, and create the outputs, the pins output sets here. Outputs sets, and here we can, instead of in, it just out. And by having so, we do have our function ready and having the right optimization. So let's take those function here, like this, and also this function too, here, bringing like this, and this one is good. So we have our function, the optimized functions here. So now we can go to the main code and see how much optimization this creates for us. So to jump on this and to change those ones, so what we can do, we can create the list of the pin that we would like to set as an output. And here, those are the pins that we would like to have an output. So let's create this list. So int, and I call it my LED list or my LED list. And this one will be an array and will be equal, and I can add all these pins here. So that's from the perspective of you knowing what you want to do. This has become very helpful. So you do have the list and you can change it easily. So PD15, and also go back again, PC12, PC2, and then PF8, then PF5. Yeah, it's quite, imagine you have to repeat this with the same function again. So this will be much easier to maintain. So after PF5, we have PE6, and after PE6, so I guess I can push this one a little bit further, and PE6, then this one, not P6, PG5, then PB6, finally PF10. Okay, then exactly the same activity can be done here. So we define the int my push button list, like button list, like this, and that will be also an array that will be equal to those elements. So we have PF4 and then PE2. After that, it's a PD1 and PB10. Finally, PD0. Okay? So now we do have those lists ready. We can really skip all this code. Like, let's initially just comment this one. So let me comment the whole thing here, and we can replace all this even more because I'm setting up all these LEDs and all these output and inputs. So what I can do is just use this pins function. So let's start with the output set. And for this output set, we do have this, my LED list as an input, my LED list, and there's 10 LED that 10 output that I would like to set. And after that, pins input set, and this is the array of the list of the LED or the pins that I would like to set as an input, and there are only 5. Okay, so by having so, let's save and build just to see how things are going. So 0 error, 0 warning. And let's see now what this is doing to our code. So let's bring back the video. Okay, so we do have our circuit, and let's load our code. Okay, of course, this is a good error. I think it's a healthy error. We need to go to debug, select the ST link here, then go to setting, go to here, reset and run, and then uncheck enable. That should be good to prepare ourselves. So build again, and yeah, let's build it and load it. Okay, so what it gives us here, we do have the first pin that we selected. So this one is getting the pin number 2. Let's see it together. This pin here. So by pushing this one, we do have the PA. So the PA0 is only connected to PA4. So the PA0, and we will see how to improve this because this is still quite very difficult to understand. So if I go here, PA0 should be the output is the first one, and PE2 here. So let's click on the other one to check. So I have a response for this pin, another response for this pin, and another response for this pin, and finally this pin. So these pins are mapped, but not in the best way that we would like to have. And here comes the next step of our code, where we are going to giving some definition to what we are to do, and this is by using the define. Okay, let me hide the video and go back to the define. So you could see this code here. You still have an image about PA0, PA4, and let's close this one, but still, let's hide this too because we don't need it anymore. We would like to have a more understanding of what we can do. So let's keep this one here, and let me show you what we can do. So if I put here define, and I can say red push button like this, and this one with the red push button, it means how it will interact with the first one. So my first push button is PA4, and I do have, let's connect it with one of the first LED, this one. So we can put here, define it as the pin right, here, pin right, and we do have PA0, so we would like to have the PA0 here to get high, or to get, not to get high, but to get the response, the pin read of the first one, the PA4. PA4, like this. Okay, and I should close this one correctly. So now, and let me add another one just so you can grasp how useful this can be. Like this. So we should not have the same name, and usually the define should be fully in capital letters. So this one will be a tilt. Okay, so this is a tilt, and instead of bringing PA4, let's bring PC4 here. So PC4 and bringing the tilt here. So by having these definitions, let me also comment the whole code here, because we would like to have a little bit more better expressed code like this. And if I bring this to just definition that we bring like this, and also the red tilt button like this. So let's see what will happen to the code. So let's save, build, and then load. Okay, so let's now bring back the video, and you could see that initially we do have this one is blue, but if I click on the red one, okay, I think I made a mistake here. So what do we have? Let's check back the code. So we do have the PA, yeah, of course, because that's a mistake here. So the PA0 is the pin. So what I need to do is PA0 and then PC4 here, PC4, and this one should stay PA4, okay, because I'm trying to control this one. And that's also what driving the mistake. So if I go here and I define, and so this one is red LED, I put red LED 1. No, that's actually a blue. This is a blue LED. So, and if I put like this, blue LED is PA0. So what I can here, the B LED, and let's have an ender bar to give it more sense. So I bring this one here. So a blue LED, what I would like to put is a blue LED get on when we do have this PA4. So let's save, build, and now we should get a much better picture. So let's load now the code. Yeah, and I do have a green LED, which is the PC4 connected. So if I click, I'm going to click here, and it's switching to the blue one, which is exactly what we wanted here. So you can use this define, and let me back here. You can use this define to optimize further your code. So for example, you can also define, and this can be used locally in your main code or when you have an application. So your first layer will be the PA0 when you really don't know exactly which pin you're using. So this can be very helpful. But later on, to have more definition in your code, this one is, let's call it green LED, and this will be PC4. So I can put here the green LED is written here. Okay, so let's save, build, bring back the video, and load. Okay, so still the same thing, but now I have a much better definition of what I'm using. And this is quite interesting and very helpful when you are making a code that you don't get lost in it. And especially when, in this example, I purposely selected all those pins so you can see sometimes it can drive you to confusion. Okay, I guess we don't need this one anymore. We can close it and jump to the last part when you can see how using this function, the function that we created initially, can really give us a really a much optimized way to do this. So no, I'm not going to use this, but just use this one like this. And let's have an int, declare an int I, because we are going to use the loop for, and only one with one loop for, we can control the whole thing using those lists that we created. So what I'm going to do, so for I equal to 0, and then I less than 10, or the number of, here I'm using a magic number, which is not good, but I should create also here like this, int LED number equal 10. We should not, like this is always, should always not use a magic number. So let's bring this. So LED, and put this LED here, number, and bring this everywhere here. Should be same for the input, like this, and I++. And where's the plus? Here. Okay. So bringing back to here, what we can do, and quite simple, we can take this function here and going through, instead of going through those one, we can go here through the list that we do have here, my LED list on this one, providing I as the number we are going through. And in this one, we are going to go through my push button list. And instead of having I, we will have I divided by 2. Okay, so you will see on this one, which means for every 2 LEDs will be controlled by 1 push button. And why we can use this, because as I is an integer, when we divide by 2, we will have from 0 to 4, as the number here goes from 0 to 9. So let's see how it works. Build, and then let's bring here and let's load. So everything went dark for the LEDs or off, but each time I'll be clicking, okay, something is not working. And it's interesting when it's not working. Let's quickly confirm. Okay, the code should save. Okay, my push button list. Let's check. It's not working. That's good. That's a good challenge. And I'm not doing this in purpose, but I think it's good to discover the code. So pin right, I++. What we can do, let's go for debug and see what's going on. So let's show here and run our code just to see what's going on. So our code is not getting inside, so the while loop is clearly here. Are we stepping? Yes. So for I equals 0, okay, it says LED number equals 0. Fantastic. That's immediately what shows. So how I found this, because the loop never goes inside. That's a mistake. You probably have seen it when I was writing the code, but by debugging, I see that the for loop never goes inside. And just by clicking here, I see the LED number is equal to 0. Yeah, it's a dumb error. It's a Sunday error. Okay, and let's save, build again, bring back the video. Okay, and load. Okay, hope now all is good. Yeah, you can see that now this is generating 2 colors at the same time, or turning 2 LEDs on at the same time until we get to the red LEDs. But here we have only the last LED. So the last one is not working. Let's check why. So from 0, so check the LEDs. To have LEDs number is 10. I check if I put it all of them. And of course, this is not a P, this is a PF0. Somehow I have put it PF10. Yeah, it's a, sorry, the mistake was here. Let me show you back. Initially, I have put this one PF10, but the correct thing is PF0. So let's build load and bring back this one, load our code, and we should see that now the 2 LEDs are on and our code is good. Okay, that was the last part of this code. I hope for today you could enjoy seeing how we can optimize our code using different ways, bringing functions together and having a batch of LED to get set together. Also, we have seen how the define is working. Finally, we saw some optimization in our code. I really thank you a lot for today and wish you a wonderful Weave Day. Bye-bye.